16th question. Whoa, the question is quite long, and even if you see the figure, that may be a bit scary one, but as you decode it, and if you're not satisfied with that, I'll show you the options that seems quite longer. Well, not to scare you, but the conclusion is that we'll go step by step and we'll see how to decode this particular question. By the way, what's the question? The question is something here. You could see two identical parallel plate capacitors of capacitance C each have plates of area A separated by distance D. The space between the plates of the two capacitors is filled with three dielectric K1, K2, K3. And both the situations are connected to a battery of potential difference V. So this is connected to a battery of potential difference V. Likewise, this is connected to a battery of potential difference V. And we need to calculate the ratio of energy stored in the capacitor. Okay, that is the given thing which has been asked. I think we need to solve by calculating the net capacitance in the individual one. Okay, so here let's see. This one is a case of a series arrangement. Okay, and how can we do that? First calculate C1. Now I'll show you C1. That will be K1 epsilon naught A upon D by 3. That will be C1. Likewise, for C2, you can do K2 epsilon naught A by D by 3, and C3, everything would be same except for K, that will become K3. So C1, C2, C3 is known. And here, what would be the capacitance of this part? So just to avoid confusion, let me call it as C1 dash. So if I call this as C1 dash, that will be K1 epsilon naught A by 3 divided by D. That's the capacitance of this arrangement. K1 epsilon naught area is 1/3 of the A divided by D. Likewise, C2 dash, C3 dash, we can calculate. Okay. So what we have done is that the individual segment of the capacitance we've calculated. And in the first case, you would get 1 by C series, let me write, would be equals to, of course, 1 by C1 plus 1 by C2 plus 1 by C3. Likewise, CP would be C1 dash plus C2 dash plus C3 dash. All right. So we calculated the capacitance in both the situation. And how about the energy? Well, the energy is, of course, not a surprise, is equals to half of CV square. So this time that will be directly proportional to C, because in both the situation, the potential difference is same. Now, E1 is to E2 would be equals to C1 is to C2. You do that, a bit of calculation is required, and then you would come, option number 3 would be the correct option for this question. Conceptually, it's not difficult, but yes, you require a presence of mind. That part is acknowledged when it comes to calculation. But then, in examination, you're choiceless. When you get anything, you need to fight in a very joyous manner. That is very essential. Fair enough. Let's go to the next one. Question number 17 from modern physics. You see, modern physics reigns when it comes to JEE Mains examination. And photoelectric effect. Well, it is the situation, something like this, that the stopping potential versus frequency of the incident light is given, and we know that comes out to be a straight line in this given way. And from this, we need to calculate the walk function of the metal, and the metal is sodium. Well, the better way would be, at this given value of frequency, the stopping potential is 0. That means this is the threshold frequency, which is 4 into 10 raised to the power 14 Hertz. And once you calculate the threshold frequency, walk function is simply h times nu naught. So that was kind of very straightforward, which indeed every question of modern physics is. And option number 4 would be the correct one. Let's move to the next. Question number 18, that has been put from kinematics. There is the projectile, a trajectory has been given, 2x minus 9x square. And on the basis of this, we need to calculate the angle of launch, which is theta naught, and the speed of launch, which is v naught. This is a very straightforward question where you get y equals to x tan theta naught minus of half g x square by u square cos square theta naught. U is the initial speed that I've written there, which here is denoted by v naught, and that hardly matters. There is the trajectory. The coefficient of x is 2, and here is tan theta naught. So just by comparing, you get tan theta naught equals to 2. By the way, tan theta naught is 2, but the option, if you see, is in terms of sine or cos. And that's not a tough deal, right? So tan theta is here, and you get sine theta naught. That's 2 by root 5. And cos theta naught would be 1 by root 5. Okay, so this was just done in order to comply with the given option. And sine theta naught 2 by root 5, cos theta naught 1 by root 5. If that is the situation, option number 1 and option number 2 would be eliminated just on the basis of the sine and cos. Rest is quite simple. The coefficient of x square is 9, and here the coefficient of x square is g by 2 u square cos square theta naught. This is the option, and the coefficient of x square, here is 9. You equate it, and when you calculate it, you will get the speed of launch is 5 by 3 meter per second. So option number 3 is the correct for question number 18. Time to move to question number 19.